Hi everybody, let's touch on some basic and advanced information about Kubernetes. And this is for anyone who might want to have an overview of this technology, because Kubernetes is the key to unlocking digital transformation. And you'll find many programmers are getting confused between Docker and Kubernetes, so this brief introduction will definitely be necessary for people out there. So in simple words, Docker is a container and Kubernetes is a container orchestration tool. It's something which can do creating, destroying, and managing containers at scale. And the abbreviation K8 is derived from replacing the 8 letters of Kubernetes with the digit 8. And the Kubernetes project was open sourced by Google in 2014, after they had used it to run production workloads at scale. And they did that for more than a decade before releasing it. And Rancher unlocks the full potential of Kubernetes, and it's a complete software stack for teams adopting containers. It addresses the operational and security challenges of managing multiple Kubernetes clusters, and that across an infrastructure, while providing DevOps and their teams with integrated tools for running containerized workloads. And a node is a worker machine in Kubernetes, and maybe even a virtual or physical machine, depending on the cluster. And each node is managed by a control plane. A node can have multiple pods, and Kubernetes control plane automatically handles scheduling the pods across the nodes in the cluster. And Kubernetes is a powerful and extensible open source platform. And this is for managing, scaling, and deploying containerized applications and services. And it's a system that's designed to handle the scheduling and coordinating of the containers on a cluster and manage the workloads to ensure that they're running reliably. So pure open source Kubernetes is free, and that can be downloaded from the repository on GitHub. And administrators must build and deploy the Kubernetes release to a local system or a cluster, or to a system or cluster that's in a public cloud, something like AWS, Google Cloud, or Microsoft Azure, whichever way you want to say it. And having knowledge about Kubernetes gives you a more holistic view of the entire software lifecycle, and particularly in large organizations. Development is usually seen as writing, reviewing, merging code, after which a CI pipeline comes along and deploys it. And Helm is a Kubernetes deployment tool for automating creation, packaging, configuration, and deployment of applications and services to Kubernetes clusters. And pods are simply the smallest unit of execution in Kubernetes. And this consisting of one or more containers, each with one or more applications and its binaries. And pod is just a co-located group of container and a Kubernetes object. Instead of deploying them like separately, you can deploy a pod of containers. And the best practice is that you should not actually run multiple processes. And a resource is an endpoint in a Kubernetes API that stores a collection of API objects of a certain kind. That sounds abstract, but that's what it is. And really, for example, the built-in pods and their resources contain a collection of pod objects. And a custom resource is an extension of the Kubernetes API that is not necessarily available in a default Kubernetes installation. And developers don't have to be experts in Kubernetes, but they should be proficient in skills that can impact the performance of their applications. So skills such as CI/CD to production, monitoring, and understanding CPU, memory, and cluster and pod health are vital pieces of the application puzzle. And although Docker is not needed as a container runtime in Kubernetes, it still has a role to play in Kubernetes ecosystem. And this also in your workflow, because Docker is still going strong as a tool for developing and building container images. And that is also as well as running them locally. And Kubernetes is a standard in container orchestration and deployment management. It can be difficult to learn for someone who's not familiar with the traditional hosting and the development environments. And it's definitely imperative to understand Docker if you want to get into Kubernetes. So in a nutshell, Docker is a suite of software development tools for creating and sharing, for running individual containers. Yeah. And Kubernetes is a system for operating containerized applications at scale. So the size, and Kubernetes applications are enterprise-ready containerized solutions. And these have pre-built deployment templates. And these are featuring portability, simplified licensing, and consolidated billing. They can be run on things like Anthos in the cloud, or even on premises on a Kubernetes clustered hosted in another environment. And Amazon Elastic Container Service for Kubernetes, which is like EKS, is a cloud-based container management server that natively integrates with Kubernetes to deploy applications. And Minikube is a lightweight Kubernetes implementation that creates a VM on your local machine and deploys a simple cluster containing only one node. And Minikube is available for Linux, macOS, and Windows systems. So since pods are ephemeral, a service enables a group of pods which provides specific functions, web services, image processing, that kind of stuff, to be assigned the name and unique IP address. So that's the cluster IP. A replica set is one of the Kubernetes controllers that make sure we have a specific number of pod replicas running. So remember that a controller in Kubernetes is what takes care of tasks to make sure that the desired state of the cluster matches the observed state. And remember that every container in a pod runs on the same node, and you can't independently stop or restart containers. And some usual best practice is to run one container in a pod, and that with additional containers only for things like an ISTO, network proxy, sidecar. And the key differentiator between containers and virtual machines is that virtual machines virtualize an entire machine down to the hardware layers, and containers only virtualize software layers above the operating system level. Namespaces are a way to organize the clusters into virtual subclusters, and they can be helpful when different teams or projects share a Kubernetes cluster. And requests are what the container is guaranteed to get. And if a container requests a resource, Kubernetes will only schedule it on a node that can give it that resource. If we look at the limits, on the other hand, make sure that a container never goes above a certain value. So when you're working with Kubernetes and want to list down all the resources, so that's the Kubernetes objects that I'm referring to, associated to a specific namespace, you can use individual kubectl get commands to list down each resource one by one, or you can list down all the resources in a Kubernetes namespace by running one single command. And CPU resource is always specified as an absolute amount of resource and never as a relative amount. So for example, 500 meters CPU, that represents roughly the same amount of computing power whether that container runs on a single core, dual core, or 48 core machine. And K3s is a highly available certified Kubernetes distributed design for production workloads in unattended, resource constrained remote locations or inside IoT appliances. And the idea of using Kubernetes is simple. You have a cluster of servers that are managed by Kubernetes, and Kubernetes is responsible for orchestrating your containers within the servers. And you treat servers as servers, and you run the applications with self-contained units that are called containers. And this is just the basic knowledge that you need to know before getting into Kubernetes and getting involved in this technology. So thanks for listening. My name is Ian Hillman. Please comment, rate, subscribe, smash that like button if this video helped you, and see you in the next video.